There is a memory protection bypass vulnerability in Siemens PLCs.
Hey Ganesh, I think you've got a story for us today about a possible bug in the Siemens programmable logic controllers. Is that correct?
That's right, Manny. Basically, this is based, there's a kind of series of vulnerabilities, but eventually what it does lead to is a kind of remote code execution vulnerability. There's a researcher who found this bug recently in some of the 2 versions of Siemens PLC devices. And it has been given some CVSS score of 8.1, which is pretty high, I think, out of the scale of 10. What it does is, even though restricted access to the users, somehow if this bug has been found, anybody can actually, basically an attacker can access this user interface, and they can leverage into doing damage to these programmable logic code. Basically, I think changing some code, maybe downloading some sort of coding, and also basically hiding under the need to basically do some sort of propagation. That is the threat vector here. But eventually, the researcher said, even though it's critical, there is no known exploits observed in the wild. And luckily, last Friday, Siemens has given a firmware update to address this vulnerability. And whoever is basically running these vulnerable devices or PLCs should upgrade as soon as possible. And what is the interest? How someone would know how the access to these Siemens devices are happening? Typical network access seems to happening via port 102 TCP, and I think any increase in activity on this specific port could be an indicator to some sort of activity occurring. In the graph, what I'm showing it here is basically in the past 90 days how the volume of the traffic is occurring, and as you can see, in the last week to 9 days, the volumes are relatively low compared to the previous weeks. Let me say previous days. But at the end of the tail end of the graph, basically, I think around the time when the upgrade has been, patches have been given, there seems to be little interest, renewed interest in looking for 102 activity. Typically at the peak, I believe the number of Unix courses has averaged about 350 to 400 per hour. But I think after the patch has been released, at one point it peaked up to 100 and seems to be coming and going in there. But I think there will be some sort of activity we would see on this port for the next few days, since some sort of research as well as the patches have been uploaded by the Siemens. And besides that, this is not the first time Siemens PLC has been subjected to some sort of remote access and basically changing the code for leveraging, damaging consequences. One of the very first ones is the infamous Stuxnet worm, I believe in the year 2010. That was one of the first well-known ones where a series of multiple Windows vulnerabilities are leveraged to basically change the code of the PLCs and eventually causing the damage to the various Siemens PLC-based controllers. And the researcher also talked about different threats besides Stuxnet, but I think of all of the very interesting and very infamous one is the Stuxnet.
That's very interesting. One of the things that I know from my personal experience working on PLCs way back when, pre-Stuxnet, in the late 90s. They're used for industrial controls. They're used for industrial factories, process piping, really anything that can control physical devices such as valves, fans, blowers, pumps. You can use it for a lot of other things as well, but that's what my initial experience is. To in my personal opinion, to get rid and not be too concerned about the remote code execution status for PLCs is to always keep your networks completely separate. Now, obviously, in today's day and age, you can't do that. You'd have to have a Bastion or a DMZ, very specific ways to connect a computer-based, Windows, Linux, Mac sort of based network into an industrial control factory or process to make sure that you update things, make sure that your timing's right or whatever. But it's still very dangerous. If you could, in my personal opinion, keep those absolutely separate. Try to make sure that any sort of work that you do on the PLCs is in an isolated environment where you don't have to have too much concern over malware or nefarious behaviors. Being able to get into that network would probably be key. But again, in today's day and age, it's too easy to just be able to have a specific office go in and do configurations on flows within the use of a PLC. But I mean, this is extremely interesting to see this bubble up again. And then, as you said, Stuxnet. So that concern's always there.
I'm not sure if you touched on this piece of it, but from this particular vulnerabilities perspective, and I think you touched on it, and Tony, I think, touched on it a little bit as well. You need network, you need actual network access to the device itself. And so the hope is that these types of devices aren't sitting straight out on the internet, but unfortunately we know that that's not true, right? And so I think one of the protections that you could at least consider is that if it doesn't need to be, it shouldn't be connected, right? It shouldn't be connected to anything. It should be in its own network that is, in essence, closed off from anything else, right? These devices shouldn't be able to be talked to by anything else on the network in a perfect world. The other interesting thing that I saw in the article was also it talking about its ability to this vulnerability, if it's actually exposed and so somebody takes advantage of it, it actually hides or avoids detection because of the way that it potentially writes directly to it writes its data code directly to the protected memory, right? So unfortunately, in that instance, you don't have anything that's sort of being written to disk. You have something written directly to memory, and a lot of our security tools are going to have a tough time actually picking up on this if somebody was able to get onto your network and then deploy the vulnerability against your devices. So I found that interesting because that poses a little bit of a problem if in fact you do have these devices and you do suspect that they have been connected and somebody was able to get onto these devices. You might have a tough time trying to decipher whether somebody actually compromised it.
That's really true and points, Tony and Manny. I believe actually the attack surface itself is very complicated. Only advanced and persistent attackers could able to, like you explained, get onto that level. And there's the explanation. And one way would be probably a question to Tony. Does there any sort of a code kind of validation, like any changes to code changes would help in this scenario? Like, for example, if the attacker has to do something, changes to the code, whatever the executable or the file itself, there should be some modifications. So will that help? Like in the traditional senses, we have a monitoring with respect to file monitoring, right? Does that help in this scenario?
Going back to when I worked on those, and it was quite a while that I did. So I'm sure that the technology has changed drastically. But from my experience, I would state that code checks, making sure that whatever is programmed, you have something to maybe even, do a comparison, would be able to alert you on if something was altered. Now, that's from my experience from a while ago. When things are sitting in memory, I don't know how or if they could do any sort of comparison to make sure that there's still integrity. That's a really good question. And that's something that I'll personally, after our discussion, I'll probably do some research just because it would be neat to see how far along the PLCs have gone since I worked on them.
Thank you, Tony, that elaborate explanation. And like Manny said, anything in the memory, writing to the memory is a concern. It's always a concern, but basically that's how some of the rootkits work, right? They try to step behind and write it to the memory, which is undetectable most often times. So. Right.
Yeah, and I tend to agree with you, Tony, that I think it would be difficult. And again, I have limited understanding of what these devices are, how they work. I've never worked on them before, but I think when you're talking about the ability to write to memory, your traditional controls are going to be limited in their capabilities of detecting this, and if the malicious code that's running in memory is capable of sort of doing rewrites, right, of any kind of code that's currently running, it might be only changing that code in memory, in which case if you did do code checks, like on disk code checks, you might not pick it up, right? Yeah. And obviously if you're sophisticated enough, you might even be able to sort of rewrite it and then rewrite it, run it, and then rewrite it back to its original form so that any kind of code checking would never be able to pick up on it. So, I think, the sky's kind of the limit when you get this kind of access. So, I'm saying that, I'm with you, Tony. I think it would be very difficult to pick up on this stuff.
Yeah, and to your point, as you were talking, I was thinking about it with the way that I used to use PLCs. If you had thermal sensors or flow sensors monitoring a process piping plant and you're undetected in memory, you can go through the logic, make a switch where you change a sensor to always say that it's good or the temperature is nominal, then make something else, alter something else that would increase or go past that security sensor, and then once that happens, it picks up the trigger that something bad has happened in the plant, and then reverse it back. Unless you know that the malware is there, you'll never know what happened. They'd probably blame faulty sensors sitting in a process piping plant, and that's frightening.